Hi, thanks for checking out our channel here. This is going to be hopefully a repair video, at least a testing video at least, on this unit. This is a Cashman's CS6000. It's a 6 joule output unit, probably like 10 stored joule, somewhere in that range. Pretty good use for the most part. They got some quirky things, I mean, but for the money, a couple $100 or so for a 6 joule, I mean, not bad money for the cost. This unit is about 11 years old. Manufactured date on the back is 05 of 14, so that's May of 14. So what, almost 11 years ago it was manufactured. So got a little age. I don't know if it's ever been worked on or not, but if it hasn't, I got 11 years or 10 or so years out of it before it crapped out on him. His note says works but very weak output, so we got to figure out what's causing that deal. So we'll check the capacitor out, look at the board, look at that transformer. That's where I'm leaning towards the transformer having an issue. I don't know if that's gonna be the issue, but we're gonna look at it anyways. Alright, so let's get the tool, the tray to get this open. This one? Yep. Alright, so we're going to pop this open. So either someone put those screws in real tight, or it's never been opened up before. The good thing is all the parts are available for it. This isn't a throwaway model. Well, yeah, it looks nice. First thing I like to do is look at the transformer on the back side. A couple cracks there, but that's not that bad. Sometimes if you see a lot of cracks or swelling on this little crease here, see it bubbled up or cracks in it or a hole in it somewhere, that's a telltale sign of a transformer going bad. Got a couple small cracks, so not sure. This being as old as it is, we're going to check the capacitor. Unplug one wire from it, and then I'm going to loosen up this nut up here in the back. I don't know what size it is. A 40 microfarad capacitor. So let's get a multimeter out. Put on capacitance. There's not a polarity to it. Going across it should be around right around 40. We're in 36.8. Oh, that's pretty close. Not going to get much better than that besides being spot on at 40. So it's got a plus or minus 5%, so a little bit past that. But I think for the cost, I'll leave it alone. Not going to gain that much energy replacing $30 part or however those capacitors run. Alright, so let's plug it in, and see what it does. Alright. Sounds healthy. Use our fancy meter here to check the output. Turn it off for a second. Pull these knobs off the bottom here. Alright, we'll look at this number here to start with. Should be about 6,000, 7,000 volts, something like that. Okay. I'm getting 0.9. Alright, so now what we're going to do is pull transformer wires off because this output board could be our problem. So this is taken out of circuit now, so the transformer, if it's good, it should show good voltage here. Now I mean that this board's bad. It still shows low, transformer's bad, and the output board's probably fine. So now let's check it again. Let's get the wire plugged back in again. $1,000 volts, so we gained 1,000, or gained 100 volts. Well, transformers are our issue, and that's the assumption right now. Okay, let me go grab another one. Alright, so there's the new transformer. It's kind of surprising because it get those two small cracks in, but I've seen them ones that look a lot worse. Or look just about the same. It's still pretty good on the output. And I've seen other ones that look way bad, way worse, or not as bad, or something, and still be okay. Alright, so we'll pull that out. Put that in. Reason why grabbing it with this, because I can discharge the capacitor, and I don't want any little bit of voltage or metal coming through and biting me. Come on. Come on. Oh, get on there. Okay. All right, let's turn around. Get this this little gun shy, because I don't want to get hit by something that shouldn't hit, or I shouldn't have been touching. Okay, there's that. Go ahead and put this capacitor back in here. I'll tighten that up here in a second. Let's go ahead and plug this back on here. And we'll test the output again. Right terminals. It's a proof that transformer was indeed our issue and that this board is good. Alright, I'll take this, plug it in here. There we go. 6.7, 6.5, usually between 6,000 and 7,000 volts. Let's see what the pulse speed is on it, how fast it pulses and stuff. Alright, well, it pulses every 1.4 seconds, that's what the number on the left means, and the actual shock duration that's on the fence itself is on for 0.07 milliseconds, so pretty quick bite on the line. They're not a constant current, but it pulls every 1.4 seconds. So let's flip this back up here, start putting a load to it and see how many joules we're getting. Now the voltage was reading what, 6.6 or whatever it was, 6.7, and now since we're going to make it do a little bit of work, the numbers probably fall a little bit, and the joules will start to climb up. So we're at 5.8 kV at 2.7 joule. So let's load it down a little more. 5.2 joule, or 5.2 kV at 5 joule. We're at 6.5 joule output at 4.4 kV. So this thing is actually a little hotter than what they state, which is good. I'd rather have a manufacturer understate than overstate. Oh, it's a 10 joule unit. And it only puts out 9.2. And we'll round it up to 6. Or round it up to 9. Or to 10 because it sounds better. So there we go. Unit's ready to go back to work again. Alright, that was a fun little repair. I like these units. Not too bad to work on. Everything's modulated, everything's plug and play. Dick around a bunch of BS, wires everywhere. Drill, screw gun go. Where'd it go? There it is, right in front of me. Only thing I need to do, I'll take it back apart. The little red light is kind of supposed to be centered on this lens here, and it's like down at the bottom edge here. So I need to open it back up and move it up just a little bit. But that's a cosmetic deal. I'll do that here in a second off camera. All right, until next time. See you guys later on. Have a good rest of your day, and like to send me some work. I'll be happy to look at them for you.